Okay, number 40 says, working by herself, Mary requires 16 minutes more than Anthony to solve a math problem. Working together, Mary and Anthony can solve the problem in 6 minutes. If this situation is represented by this equation right here, where t represents the number of minutes Anthony works alone to solve the problem, how many minutes will it take Anthony to solve the problem if he works by himself? All right, well, this equation is actually all set up for us already. So really, all we have to do is just find a common denominator, cross off the denominators, and solve from there. Okay, so I'm going to take this 1 and put it over 1. And our common denominator, I mean, there's no way to get this t to say t plus 16. Like, there's nothing you can multiply it by. So it says t plus 16. So our common denominator is actually going to have to be a t times a t plus 16. We're going to have to include both of these denominators in our common denominator. So let's start by writing that. And even on the right-hand side of the equation, we need a t and a t plus 16. All right, so if we look at this first fraction, we want to say, well, what is this denominator missing that our common denominator has? The t plus 16. So I'm going to multiply the numerator and the denominator by t plus 16. All right, in our second fraction, we have the t plus 16, but we're missing this t. So I'm going to multiply top and bottom of this by t. And then our last fraction is missing the t as well as the t plus 16. So let's put both of those in the numerator and the denominator. Okay, so let's multiply. If we distribute the 6 to both terms on top, we will have 6t plus 96. And then we'll have plus 6t, and then equals, well, let's just distribute this 1t to both terms here. So it's going to be t squared plus 16t. Okay, now that we have a common denominator, let's just take them and cross them off, and let's solve what we're left with. So we have 6t plus 96 plus 6t equals t squared plus 16t. All right, well, I'm going to actually move everything to the right-hand side of the equation, because if our t squared is positive over here, we don't want to bring it to the left and make it negative. So, I mean, if you combine the 6t and the 6t, that's going to give you 12t. And so then if we move everything to the right-hand side of the equation, we're going to have to subtract 12t and also subtract 96. I'm going to line up the 12t under the 16t, but the 96 doesn't combine with anything there, so you might as well just put it off to the side. Okay, so everything on the left cancels, so we have 0. And on the right, we have t squared, and then 16t minus 12t would be 4t, and I can bring down my minus 96. Okay, so this is your basic trinomial factoring. So I'm going to put a t in the first spot in each parenthesis, and I want to come up with two numbers that multiply to negative 96 and add to 4. So if they multiply to a negative, they have to have different signs. And our two numbers, let's see, are going to be a positive 12 and a negative 8. Now, when we go to make our t-chart and solve, we wind up with t equals negative 12 and t equals 8. Now, one of these answers really makes absolutely no sense. If you realized it was this one here, the negative, you're right, because you can't have negative time. So I'm going to cross that off. So really, it's going to take Anthony 8 minutes to solve the problem if he works by himself. All right, number 41. Does there exist a pair of consecutive integers whose reciprocals sum to 5, 6? Okay, so there's a couple different terms that we have to know here. First of all, consecutive integers are integers that follow each other in order. So for example, 4 and 5 are consecutive integers, or 8 and 9 are consecutive integers. So let's just suppose I let x be the first consecutive integer. Well, think about it. If x is the first consecutive integer, how would we represent the next consecutive integer? How do we represent, really, the next number to follow it in order? So really, one more than the number we're talking about. Well, since 1 more than x is x plus 1, let's let x plus 1 represent the second consecutive integer. Okay, so then the second term you have to know is reciprocal. It says whose reciprocals sum to 5, 6. Well, reciprocal means to basically flip upside down. So the reciprocal of 2/3 would be 3 over 2. The reciprocal of 1 over 3 would be 3 over 1. So they're telling us to take the sum of the reciprocals. So let's see, the reciprocal of x would be, if you took x and made it into a fraction, it would be x over 1. So its reciprocal would be 1 over x. And it says we want to add that to, right? It says the sum of the reciprocals. Well, if you take x plus 1 and make it into a fraction, it would be x plus 1 over 1. So we want to take the reciprocal of that, flip it upside down. It would be 1 over x plus 1. And it says the reciprocals sum to 5, 6. All right, well, let's solve this and see what we get. All right, so first thing we have to do is we have to find a common denominator. So really, we need to include everything in our common denominator, the 6, the x, and the x plus 1. Okay, so I'm going to write our common denominators as 6 times x plus 1. So let's make all of our denominators say that. 6 times x plus 1. Okay, and again, a 6 times x plus 1. Okay, so if we look at this first fraction, we see we have the x, but we're missing the 6 and the x plus 1. So let's multiply this by 6 times x plus 1 on the top and the bottom. Okay, so, 1 times 6 is 6, so let's just distribute this 6 to both terms, leaving me with 6x plus 6. Okay, the second fraction has the x plus 1, but it's missing the 6 and the x. So let's multiply top and bottom by 6x. All right, so that leaves me with a 6x up here. And the last fraction has the 6, but it's missing the x and the x plus 1. So we'll multiply this by x times x plus 1. Okay, well now that we have all the denominators the same, let's just cross them right off. Oh, I forgot the numerator over here. The numerator would be, well, 5x times x is 5x squared, and 5x times 1 would be positive 5x. Okay, so let's solve what we're left with. Here in the numerators, we can combine the 6 x's to give us 12x. So we have 12x plus 6 equals 5x squared plus 5x. Now, since the x squared term is positive, let's just move everything to the right-hand side of the equation. That way we keep it positive. So I'm going to subtract the 12x and subtract the 6. Okay, so everything over here on the left cancels, and I'm going to be left with 5x squared, and then minus 7x minus 6. Okay, so in order to factor this, there's no greatest common factor we can pull out, but because the number in front of the x squared is not a 1, we're going to have to do factor by grouping. All right, so for factor by grouping, we bring down our first term, we can leave a big space, and we can bring down our last term. And what we need to do is we need to come up with two numbers that multiply to the product of these two. So it's going to multiply to negative 30, and it's going to add to negative 7. All right, so two numbers that multiply to negative 30 and add to negative 7 will be negative 10 and positive 3. So I'm going to make this a negative 10x and a positive 3x. Okay, so let's just finish doing our grouping. Out of the first two terms, I can pull out a 5x, which leaves me with x minus 2. And out of the next two terms, I could pull out a positive 3, which also leaves me with an x minus 2. So my factors are going to be 5x plus 3 and x minus 2. Okay, so now what I'm going to do is I'm going to make a t-chart and I'm going to solve. So we could see underneath the x minus 2, that one's pretty straightforward. You're going to wind up with x equals 2. Underneath this factor, the factor on the left here, if you can't just look at it and say, oh, you wind up with negative 3/5, what you can do is you can solve it. Now I'm kind of running out of room, so I'm going to solve it, I guess, over here. If we take 5x, plus 3, so if we take that factor and set it equal to 0, in order to solve for x, we would first subtract 3, so that gives us 5x equals negative 3, and then divide by 5. So it leaves us with x equals negative 3/5. Now, let's just reread the question and logically think about which answer makes sense. So the question says, does there exist a pair of consecutive integers? So an integer, this fraction right here is definitely not an integer. So we could take that and we can cross that right off. So it looks like this here would be our integer. So since x represents the first consecutive integer, our first consecutive integer is going to be 2. And x plus 1, so 2 plus 1, is 3. And if you wanted to just do a quick check, if we took the reciprocal of 2, it would be 1 over 2. And if we took the reciprocal of 3, it would be 1 over 3. And if we added those, we want to see, does it actually equal 5/6? Well, let's see. Let's find a common denominator. So we can multiply this first fraction by 3 over 3, which would give us 3/6. And we can multiply the second fraction by 2 over 2, which would give us 2/6. And if we bring down this 5/6, well, this is true. 3/6 plus 2/6 actually does equal 5/6. So this does check out for us. The last question we're going to do today is number 42. It says, the sum of a number n and 10 times its reciprocal is 7. Determine the value or values of n. Okay, so it says we want to take the sum tells us to add, of a number n, so n plus 10 times its reciprocal. So we want to do 10 times the reciprocal of n. Well, the reciprocal of n, right, the reciprocal of n over 1 would be 1 over n. And it's telling us that that is equal to 7. So let's write equal 7. Okay, I'm going to just make everything into a fraction just because we have a fraction right here. So I'm going to take this and make it into n over 1. Now, if I took this 10 and made that into a fraction, I can just multiply across. So this would give me 10 over n. So this fraction is going to be 10 over n, and I'm going to say equals 7 over 1. Okay, so now we can see our common denominator is going to be an n. So that's going to be fairly straightforward to get. I mean, our first fraction, we're going to multiply by n over n. So that leaves us with n squared over n. Our second fraction already has the n, so I'm just going to leave that 10 in the numerator. And the last fraction, we're going to also multiply by n over n. So that'll leave me with 7n over n. And now that I have a common denominator, you can cross them off. And I'm left with n squared plus 10 equals 7n. All right, well, since our n squared is positive on the left-hand side, let's move the 7n this way. And when we move a 7n to the other side of the equation, it's going to become a negative 7n. So that's going to leave us with n squared minus 7n plus 10 equals 0. Okay, be sure to write it in standard form like this, where you have your n squared term first, then your n to the first, and then your constant at the end. That way it's easier for factoring. So what we're going to do is to factor. It's just your basic trinomial. We're going to put an n in the first spot in each of the parentheses, and two numbers that multiply to 10 and add to negative 7 is going to be negative 5 and negative 2. So we wind up getting n equals 5 and n equals 2. And I mean, you could plug these numbers back into the original situation, and when you do, what you'll see is that they both wind up checking out.